the next item is we need to now think about the ball traveling vertically. So this ball not only moved from one end of the field to the other on the ground, it actually flew in the air. So we need to now figure out the vertical part of this parametric equation. So we had first established that y is going to be like basically like a quadratic function, which looks like this. All right, we said, well, we're not really going to use x's because this function is not going to be dependent upon x's. Instead, it's going to be dependent upon the parameter time. So we're going to say y equals a t squared plus bt plus c. And we're really going to think about what these three values mean in the context of the problem. So the first one is given because gravity is involved. Anytime gravity is involved with projectile motion, we're going to use negative 4.9 meters per second squared. So that's a physics discussion. So we're just going to leave it at that. That is always going to be the same with objects flying in the air. All right. Then our b value really means the initial velocity in the y direction multiplied by the time plus the initial height in the vertical direction. So we actually have that. The initial height is 1, all right? Which really means that the only part that is missing from this equation is this, the initial velocity, vertically speaking. So we can actually solve for that. We know, for example, that we know a couple of points, all right? We know a couple of moments in time. For example, at time 0, the ball had a height of 1. Now, I'm not going to substitute 0 into this function because it's just going to cancel out these terms, and I'm not going to be able to solve for v sub 0 y. But I do know the height at another time. I do know also that at time 3.6, it arrives at the other end of the field at an identical position. So we're going to say that at 3.6, it also has a height of 1. All right. So I am actually going to use this sort of ordered pair for the vertical direction to solve for my initial velocity. So let's substitute my height, which is y. All right, we're going to say 1 meter is equal to negative 4.9 meters times 3.6 quantity squared plus the initial velocity y times 3.6 seconds added to 1. And I'm not going to spend too much time showing the algebra right there because I have it right here in your Desmos notes. But basically, after we multiply and use algebra to add to both sides, we end up, all right, and I invite you to, to check out all the calculations over here, all right, we end up with 17.64 is equal to my initial velocity in the y direction. So we have solved for that linear component, 17.64. And again, you can look at this by pausing, all right, and check out the algebraic calculations. But what does that mean? Well, it means we now have a y equation. That equation is y equals negative 4.9 t squared plus 17.64 t plus 1. So we can actually put this equation to use. We can substitute any given time and find how high the ball was in the air. And one of the neatest things that you can do with this is you can substitute, for example, the time where the ball was halfway done with its flight. So half of 3.6, if you know that the ball was in the air 3.6 seconds, right? Well, if I divided that by 2, I can use 1.8. In other words, if I use 1.8 seconds, I should be able to find how high that ball was in the air simply by substituting 1.8 into this equation. And so to make my life easier, I am actually going to use Desmos for this. So negative 4.9 times 1.8 quantity squared plus 17.64 times the quantity 1.8. And finally add 1. So when I do that, I actually get y equals 16.87 meters. In other words, that's how high the ball went. It got to 16.87 meters at the time of 1.8 seconds. All right. So that's the information vertically speaking.